goes into the sine function, right? So that goes into the sine function, and it comes out as sine x. And then that answer, right, that answer goes into what? The sine function again. So it goes into sine, comes out as sine of x, and then that answer goes into sine, right? All of that goes into sine again. You've got this triple composition. So that goes through sine one more time, and you get sine of x, right? So chain rule seems to have worked when we had two functions together, right? Like composition of two. How does it work when you have three? We follow the exact same plan, all right? This is an onion with 3 layers to it. So instead of having inner and outer, we actually have inner, middle, outer. And whenever we differentiate using chain rule, we always start with which layer? Outer. So the outermost layer that I'm going to start with here is sine, right here. I'm going to start with that one right there. I'm going to start my differentiation. And I have, the derivative will be, okay, I need something kind of big here. Oh, this little bag of sanitary wipes. I have sine of a bag of wipes. What's the derivative of sine of a bag of wipes? Cosine of a bag of wipes, right? So I'm going to write cosine, and then I'm going to put all that inside of it. So cosine, and then I'm going to put in that, what am I putting in there? Sine of x, like that. All we have done up to this point is taking care of the outer part of the onion, right? Now we're going to move into the middle. I've got to start reusing things. I like the rag. So I've done that outer layer. Now I'm dealing with this. So I've got my rag here. What's the derivative of sine of a rag? Cosine of the rag, right? Cosine of the rag. So next to this, with multiplication, I'm going to write cosine of the rag, right? The rag was sine x. I've now taken care of the middle layer. Now I go to the final inner layer, which is sine again, right? And I take its derivative and tack it on to the end. So I put what here? Cosine of x. How do y'all feel? I mean, this is chain rule. I mean, you're going to have to do a lot of problems to get comfortable with this. I'm going to pull some more from the book. Some more ideas here. Where'd it go? That's actually number 36 in the book, that problem. Oof, wow, okay, I'm not ready for that yet. Oh, here's a good one. F of x equals sine the square root of x cubed plus x. Hey, there's no such thing as doing too many chain rule problems. You can never say that statement. I've done enough chain rule. That's a false statement, no matter who it's coming from, all right? If you go through and do every problem in this assignment, then just go on Google and say chain rule problem worksheet and just do more problems. And here's the thing, how many of you need Cal 2? Just, okay, look, that's basically everyone in here, almost everyone, right? So in Cal 1, we have these rules, right? We have the power rule, how you deal with powers. We have the product rule. We have the quotient rule. We have the chain rule. And even though this is a little complicated at the beginning, when you're trying to like understand how all these functions fit together and like which function's inside of which, and where's there a product happening, where's there a quotient, even though that's complicated, at some point you do get to this comfort level where you're like, okay, I get it. Like I'm just gonna follow this like kind of algorithm and I'm gonna get to an answer. In Cal 2, what we're trying to do is we're trying to do this process in reverse. And unfortunately, there's not formulas to go backwards. So the only way you're gonna get good at going backwards is if you knew how to go forward. Like it's very, in Cal 2, it's very intuitive. Like, not intuitive, that's not the word I'm looking for. It's like an intuition, and it's hard to teach a student intuition. But the thing that all the students in Cal 2 that are good, that do well in that class have, is that they're good at this. You can't suck at this and do well in Cal 2. It's impossible, right? It's like if you don't know how to walk forward, there's no way you're like moonwalking. You know what I mean? You're not going backwards. It's not happening. So, okay, terrible analogies. I was giving you time to look at this. What do you see? Composition. How many functions do you see being composed together here? 3? You don't see 3? What's the outer layer of this onion? The outer one. Sine. What's the next one in? Square root. What's the next one in? X cubed plus x, right? Gotta sneeze. Maybe. Nope. So 3 layers, right? 3 layers. So let's see if we can do this just following what we've been doing today. Who's my volunteer? Somebody new. Don't make me break out the attendance sheet. Do I have to break out the attendance sheet?
I'll go.
Okay, thank you. All right. Tell me what you're doing and then tell me what you want me to put up here.
Okay, first we're taking the derivative of the sine.
Okay.
So the outer layer is going to be cosine
Okay.
of the square root of x cubed plus x.
Okay, so you took the derivative of the outer function and then you didn't touch anything else and you just plugged all that into this.
Yes.
Perfect. But we're not done, right?
Oh, not even.
Do you want to keep going?
Sure, why not?
Okay.
Okay, times the, wow.
I'm going to kind of like mark this out like we've already taken care of that derivative. So
In parentheses, 1 over 2 times the square root of x to the third plus x.
okay, explain what you did there.
I took the derivative of the square root part x.
Yep, we had the square root of something, right? So the derivative of the square root of something is 1 over 2 square roots of that something, right? Perfect. Who wants to finish it? There's one more. Go ahead. Good job. Good. Parenthesis. 3x squared plus 1. There it is. Derivative of the outer layer, evaluated at the inside stuff. Now you go to the middle layer. Derivative of the middle layer, evaluated at what was inside of it. And then final piece is a derivative of that inner layer, which was the x cubed plus x. Derivative of that's 3x squared plus 1. That's the raw derivative. I mean, we could move things around and stuff, but that is the calculus, right? That's the only thing that's calculus. Yes. What happened to it?
Yeah,
Or where did it come from?
because we just ended up multiplying it by 3x squared plus 1.
Uh-huh.
So like, why don't we also include 2? Because
The 2 comes from when you find the derivative of the square root. So you don't think you have to remember?
oh, so then we don't need the 2 for like when we multiply by 3x squared plus 1.
I'm not quite sure I'm understanding. You're not asking where this comes from. You understand this is the formula? Yes?
Yeah.
But you're wondering,
I just thought the 2 would be included, like when we're there, but no. We're just taking inside the square root.
yeah, this right here is just the derivative of what's in here. We're not doing, I think you're looking at, maybe you're looking at this and taking its, you're looking at the inside of this and taking derivative and putting it there.
Okay, so the beginning.
Yes, always looking back at the original function. Working your way from the outer inside the onion. Okay. Let's see, another one. How are we doing? Good on time. All right. Okay, I like this one. Haven't had something like this yet. I have this student in Cal 2. I better mute this. All right, I'm just giving you time to look at that, telling you side stories. All right, who's up? Guess I'm going to go get my roster. Maybe not. I didn't bring his. Wait a minute. I thought I graded y'all's quizzes, but I didn't bring them. I was out of it this morning. I'm sorry. They're on my desk. Okay, come on. Let's go. Volunteer. I'll let people volunteer again. But those of you who are being quiet, that's either because you're shy and you don't want to talk, or you don't know what you're doing and you're too afraid to ask. So I'm assuming one of those two things, right? Go ahead. Oh, okay. Yes, yes. Quotient rule. Very good. Everyone see that ultimately we have a quotient. Boom, boom, right? Okay, let's set up the quotient rule. We're not going to take any derivatives. Let's just set it up. So the derivative here will be, you want to help? The prime of this, so the derivative of the top, right? Times the bottom, square root of x cubed plus 1. Oh, careful. Minus, now what? The derivative of the denominator, which is the derivative of the square root of x cubed plus 1, times the top x over the denominator squared, which will kill that square root off, but I'm just going to write it. Okay, very good. Does everyone see that ultimately there was a quotient rule we have to deal with? All right, very good. Who's going to continue? Not all at one time, please. Raise your hand if you want. Oh, yeah, thank you. You only have two derivatives to take, right? That's it, two derivatives. That one and that one. So what do you got here? 1. So 1 times that. Is it all right, everyone, if I just not write the 1 and I just write this? Okay, minus. Now, this is the challenging one. Well, challenging. This is the one that causes some issue here. You want to go for it? 1 over 2 square root of x cubed plus 1. Is that what you said? Okay. Times what? 3x to the power of 2 times x. What do y'all think? And we're not done, but what do y'all think as far as the derivative of this and that? Is that right? Hands up, yes? Y'all agree? Disagree? Are we? How do they do it in the old gladiator days? Is it this or is it this? What do y'all think? Thumbs up? I'm seeing a lot of thumbs up. So you did chain rule, right? You said, okay, I have composition here, outer, inner, right? Derivative of the square root of something is 1 over 2 square roots of that something, right? Times, now the derivative of what's in here. Now, the derivative of that's 3x squared, derivative of that's 0. So I put it here. I did not need parentheses here because it's only one term. If you put them, it wouldn't be wrong, but I don't need them. And then where does that come from? This right here. It's not part of the derivative. It's part of the quotient rule. I'm missing, though, the whole bottom squared. And when you square that square root, the square root goes away. You just get that. That's your raw derivative. If y equals cosine squared t, find oops. So what I'm doing here is I'm trying to change things up a little bit using different letters, different notation to see if I can confuse you. So instead of using f of x, I'm just writing y. Instead of using the variable x, I'm using the variable t. What is this asking for? What does this notation mean? Take the derivative twice. So we're going to have to take the derivative, and then after we do that, we do it again. All right? So let's start by taking the derivative the first time. And I'm going to write it like this. The derivative of y with respect to t, that would be my first derivative. I'm taking derivative of that, right? What's another way I could have written this? Cosine t parentheses squared, right? Like that. All right. Who wants it? How do you take derivative of this? You want to go? Yes, you do. Yes, you do. You got it. You got it. So what's first? Squared first. So 2 comes out. 2. And then let's just go ahead and just write it like this. Cosine t to what power? I'm sorry? You brought the 2 out, right? This now to the 1, right? I don't need it, right? I don't need the power there. I'm just showing that's the power rule occurring on the outer layer. And are we done? This is a 1, everyone. This is not a prime. Are we done with this derivative, though? Right? Remember, there was 2 layers, right? Outer layer, inner layer. All you did was the outer layer. You have to multiply and then take the derivative of that inside piece, which is, what's derivative of cosine, everyone? Negative sine. Negative sine. Negative sine t. Let me clean this up. This is 2. That's just cosine t, right? Cosine t to the first power is just cosine t. Then times negative sine t. But that's the same as negative 2 cosine t sine t. All I did there was brought that negative in front of the sign out in front of the 2. Does anyone have questions on that?
Yeah, can you just do that? Like we did it with the negative to bring it out?
Yeah, because this is like a negative 1, and this is multiplication. So with multiplication, numbers can slide around. You can move them wherever you want. As long as things are being multiplied, you can do that. It's like this. If I did 1 times 3 times -4 times 5 times 7, I can rearrange these however I want. You know, I could put the -4 out here in front. I could just like take this, look at it as a -1 and pop that in front of there, make that a -1, make, you know, get rid of it there. It's all multiplication that's allowed. This does not mean subtraction. So that's why it's so important for you to see here. We're multiplying, right, times that, right? So that's really like a -1, which you can just pull in front of everything. No questions there? We're not done, right, with the problem? We need to take derivative again. Yes?
This is really not a great problem, but I have a question.
Uh-huh.
How we have d squared y over dt squared, which of the two indicate that we need to take the derivative twice?
Both the fact that this is a 2 tells you need the derivative twice. If this were 3's, you have to do it 3 times.
It would have to be both.
Yeah, this is just the notation. If you look back in our notes, when we were talking about notations for derivatives, this was called Leibniz notation. So I'm just kind of mixing it in here so that you see it and you know what it's asking you to do. And see how the 2's are offset? That was on purpose. That's so you know that it's a derivative and not like something squared. Ready? Second derivative. So my second derivative will be the derivative of that. How are you going to do that? Product rule. Product. And if it were me, I would just do my product right there. So I have like this and this, 2 different functions. That -2 out here, I'm just going to attach it to the cosine because it's a constant. I'm just going to follow the rules with differentiation with constants. So my product rule says I'm going to take the derivative of the first one times the second one plus the derivative of the second one times the first one. Right, that's my product rule right there. And then for this, the -2 comes for the ride, right, because it's a constant attached to the function. What is the derivative of cosine t? Negative sine t, right? Negative sine t. And then I had next to it sine t, right? And then plus, what's the derivative of sine t? Cosine t. But then next to that, I have times -2 cosine t. Interesting. Okay. That's the second derivative right there. Now I'm going to do something just to clean it up a little bit. 2 negatives here become positive, so I have positive 2. And then sine t times sine t is sine squared t. And then over here, I have -2 I'll bring out front. And then cosine times cosine is cosine squared t. If this were a plus, I'd be able to pull a 2 out and use a Pythagorean identity, but it's a minus. Right? I could pull a 2 out. If I pull a 2 out, I have this, right? If I pull a 2 from both of these. If that was a plus, what does that turn into? What's sine squared t plus cosine squared t plus, if that were a plus? What is that? 1. That's 1. Pre-cal, very important formula. But it's a minus, so I can't do that, all right? So on your next test, I'm pretty happy if you get to here. But me being happy to see the raw derivative is not a substitute for you being able to algebraically manipulate these things. I do still trust that you all passed college algebra and pre-cal and that you can do algebra. Yes?
So why is the 2 not counted as the 2 times?
Oh, like a product rule on that?
Yeah, why is that not?
You're saying, why am I not looking at that as like a separate product?
Yeah.
Is that my understanding of your question? Because it's a constant attached to the function, I don't have to treat it like a product rule. Just like if I ask you to take derivative of 3x, right? Do you treat this like a product? Like in your mind, do you treat that like a product, or do you just say, hey, 3 comes for the ride, derivative of x is 1, and therefore the answer here is 3? How do you see this?
Yeah.
You see it like this? Okay. You could, if you wanted to, treat it like a product. Let's try it. If we did a product rule, first you do derivative of this, right? Times this one, then plus the derivative of that one times that, right? What's the derivative of 3 though? 0, and that would kill this whole thing off, wouldn't it? And then over here, the derivative of x is 1, then times 3, so you just get the 3. You see? So if I had treated this like a product rule, if I did, then when I do that, I'm going to get a 0 over there on that first one. And so I don't need to look at it. So that's why whenever we have a constant attached to a function, we just bring it with us. When we take the derivative, it just comes out in front. Am I answering your question? Okay. Okay, I want to try and do one more before we call it a day. Find the equation of the tangent line to the curve y equals 1 over the square root of 1 plus x squared at the point, crap. 0, 1. So from the beginning of this class, we've been talking about this tangent line thing, right? Can we come up the equation of the tangent line on a curve? We use the limit, and then now we have these shortcut rules. So this is a common theme, right? Find the equation tangent line, find the equation, it's a common theme. Just how we actually do the derivative is what's changing. We used to use the limit, now we're using shortcuts. This right here though, this derivative is going to be, well, I don't know. How do you want to look at this? You have to take derivative of that, don't you? Right? For the equation, we need to use that formula. Right? That's our generic formula. We have the point, right? We have the point x1, y1 right here. So the only thing we need is this, right? And this comes from the derivative of that at the point. On your quizzes that you took last time, and I'm sorry I don't have them with me today, there were a few of you that on the second problem, when you got the equation tangent line, this right here, you got the derivative and plugged it in here, but you never evaluated the derivative at the value of x. You actually have to plug the point into the derivative to get this slope. So we want the derivative, right? We need the derivative, and then we need to plug in the point, and then we can find that slope of that tangent line. So for this derivative, how do y'all want to do it? You have a couple options here. You want to treat it like a quotient? I'm fine with that. We can do quotient. If we do quotient, then we're going to do derivative of the top times the bottom, right? Minus derivative of the bottom times the top all over the bottom square. Right? So the top, we're going to do derivative of the top times the bottom minus the derivative of the bottom, which I haven't done yet, times the top all over the bottom squared. What can you all tell me about this? When I take the derivative, it's what? It's 0. Because what's derivative of 1? 0. So that's going to kill all this off. But we do need to still find the derivative of this, right? This is the part I think is going to be the trickiest part, is doing that derivative, because that's composition, isn't it? You have an outer and an inner layer. So you've got to be able to find the derivative there. Also, do not forget that you have a minus sign out here, right? It was 0 minus whatever this becomes. All right, so I continue. Actually, I think I'm going to write the 0 so we don't mess it up. 0 minus, all right, what is the derivative of the square root of something? 1 over 2 square roots of that something, and the something for us is 1 plus x squared. We're not done, right? That's just the derivative of the square root. Now you need to go inside and take derivative of 1 plus x squared, and you tack that on over here. What's the derivative of 1 plus x squared? 2x. Are we done? Times 1. You have to finish up the quotient rule, right? This had a times 1 out here. And then all over 1 plus x squared. And that's our raw derivative. And it's very raw, but any questions on any piece of it? Do y'all see the chain rule? Yes? All right, now to find the slope of the tangent line, I do not just plug this answer in for m. That's what some people did on the quiz. You don't just plug that in right there. What you do is we look at the point we're at, right? We're at the point 0, 1. We take this x coordinate and we plug that in for x here. So plug in x, plug in, at the point 0, 1, this becomes, well, what does it become? 0 minus 1 over 2 square roots of 1 plus 0 squared times 2 times 0 times 1 all over 1 plus 0 squared. See, I'm just replacing all the x's with zeros. Can y'all tell what you get on top? That'll be 1/2, but then times what? 2 times 0? You should just get 0 there. Like this becomes 1/2, but then you have to say 2 times 2 times 0. So all that's going to be 0. 0 minus 0 is 0. So you have 0 on top. And what about the bottom? 1. 0 divided by 1 is 0. Hey, so your slope is 0, right? You should have a horizontal tangent line. So now the equation. Come up here. Y minus, what's y1 for us here? 1 equals 0 times x minus, this actually doesn't matter, but right, that's the equation of the line. And that just becomes y minus 1 equals 0, which means you have y equals 1, which is a horizontal line.